Okay, now we will move on to the next number. In an optics lesson, a physics student traces the paths of three rays of light near the boundary between medium A and air. The student uses a protractor to measure the various angles. Figure 8.1 illustrates the three measurements. This is the first measurement. This is the second and the third measurement. Question 8a. State which is the optical denser medium, A or air, and how you can tell this. To answer this question, we have to go back to the first measurement. On the first measurement, we can see that the ray of light is refracted away from normal. See here, this is the incident ray. This is the refracted ray. The refracted ray is farther from normal. This means that the light comes from denser medium to less dense medium. So, the answer to question 8a is medium A is optically denser than air because the angle of refraction is greater than the angle of incidence, or because the ray of light is refracted away from normal. So you can choose one of the answer. Question 8b. State in which medium the light travels the faster and how you know this. As we have discussed before, the light comes from denser medium to less dense medium. So, the answer to question 8b is the light travels the fastest in air because light travels faster in less dense medium. Question 8c. State the critical angle of medium A. To answer this question, we have to look at the figure showing the second measurement. This is the second measurement. The figure on the top, this one, ray 2. On the second measurement, we can see that the angle of incidence is 42 degrees. Which one is the angle of incidence? This one. That's the angle of incidence. Remember, we measure the angle of incidence from the normal. The normal is the position of the 90 degrees here. So, from 90 degrees, let's count until the position of the incident ray. 10, 20, 30, 40, and then another 2 degrees here. So, the angle of incidence for measurement number 2 is 42 degrees. For the angle of incidence 42 degrees, the angle of refraction is almost 90 degrees. The definition of critical angle is the angle of incidence which produces the angle of refraction exactly 90 degrees. Because the angle of incidence, 42 degrees, produces the angle of refraction almost 90 degrees, then we can assume that the critical angle is slightly greater than 42 degrees. So the answer for question number 8C is 43 degrees. Number 8D. State the full name for what is happening to ray 3. Let's look at ray 3. The figure on the bottom, this one, is ray 3. As you can see here on ray 3, there are no light emerges from medium A. All of the lights reflected back into medium A. This event is called the total internal reflection. So that's the answer for question 8D. Total internal reflection. Question 8E. The refractive index of medium A is 1.49. Calculate the value of the angle of refraction of ray 1, showing all your working. To do this calculation, we have to visit the figure 8.1 once again, showing the first measurement. On this figure, we can see that the light comes from medium A into air. That means the first medium is medium A, while the second medium is the air. The angle of incidence, this one, equals to 42 degrees. From those data, now we can calculate the angle of refraction. To calculate the angle of refraction, we will use the Snell's formula. N2 over N1 equal sin I over sin R. Remember, N2 is the refractive index of the second medium, N1 is the refractive index of the first medium, I is the angle of incidence, and R is the angle of refraction. N2 is the refractive index of air, since air is the second medium. From the figure, we have seen before that the light comes from medium A into air, so air is the second medium. N2 equals to 1. Once again, you have to memorize the refractive index of air equals to 1 over 1.49. This is the refractive index of medium A, equals to sin 42 degrees. This is the angle of incidence over sin R. Then we have sin R equals to 1.49 times sin 42 degrees. This equals to 0.997. R equals to inverse of sin 0.997. This equals to 86 degrees. This is a round off number. So the angle of refraction equals to 86 degrees. Let's continue to question number 8F. The speed of light in air is 3 times 10 to the power of 8 meter per second. Calculate the speed of light in medium A, showing all your working. To answer this question, we will use the formula refractive index of a medium equals to speed of light in vacuum or air over speed of light in the medium. From the problem, we know that the refractive index of medium A is 1.49. This equals to 3 times 10 to the power of 8, which is the speed of light in air, over v. V is speed of light in medium A. So v, or speed of light in medium A, equals to 3 times 10 to the power of 8 over 1.49. This equals to 2 times 10 to the power of 8 meter per second. This is a round-off number. Why we have to round it off? Because we have to consider the number of significant figures used in the problem. Let's put that on the provided space. Speed of light is 2 times 10 to the power of 8 meter per second.